If you haven't heard my greeting before, I'm Catherine Glowinski. I am a software engineer on the data team at Quantopian. I'm here today to introduce Anshul Vikram, who is a CEO and founder of Accern, a big data company. Anshul works primarily in data visualization, quantitative and behavioral finance, text analysis, and machine learning. And his talk today is going to be needle in a haystack, mining for actionable information in a noisy web. Welcome, Anshul.
Thank you, Catherine. All right. Is there a clear slide? Good. Okay. Thank you for the introduction. I've been told that I need to put my research cap on and try to make this talk more educational than more practical, which is crazy. Anyway, so today the talk is going to be about needle in the haystack, mining for actionable information in the noisy web. This is actually a controversial topic. No one wants to talk about the noise on which they are trading, but everyone wants to talk about social analytics. So I will try to do my best to cover the aspects of noise cancellation, especially when you are looking into the World Wide Web data, which is 6 million, 7 million articles a day. You are crunching more than 200, 300 terabytes of data every year. So before I go into the details, let me give you a brief background about Exxon and myself. So I'm actually the co-founder and CTO, not CEO. My CEO is right at the back. Okay. So we founded Accern in 2014. We provide social analytics solutions to institutional and retail quants. We have 3 products in the market. Some of you might know us because of all the strategies that we post on Quantopian platform. So we have Alpha Stream, which is a real-time data feed that institutional investors can use. It's super low latency. We have Alpha 1, which is an aggregated feed. Now, basically, the main difference between Alpha Stream and Alpha 1 is twofold. First is that Alpha Stream covers around 25 different metrics. So it covers things like what is the virality score, what is the rank of the source from this information is coming, what is the probability that the information that is posted may go viral in like next couple of hours, right? Alpha 1 has only 3 metrics at this stage. So it is a daily aggregate of all the information that you receive in Alpha Stream, basically delivered to you end of the day, every day. And it's available on Quantopian and Quandle, from where you can just use the stream. Then last month only, we launched a visual analytics platform. And I'm going to touch very briefly at the end of this talk, like what it looks like and why we had to build it, basically to make your life simpler and our life simpler as well. About myself, I am a PhD candidate in big data visualization and analytics at NYU. In not my previous life, but previously, I worked in wearable technologies, artificial intelligence, and robotics. So if you ever come across a video that shows people kissing robots and robots kissing back, I'm the culprit. So that's basically my previous life, and I did a bachelor's in engineering and electronics from India, from BITS Pilani. So while I had to figure out a talk title, I came across this beautiful picture. So this was an artist back in 2014. He spent 2 days, literally 48 hours, finding needle in a haystack. And we were just laughing at it, and we realized that there is a very contrast similarity between what he is doing and what we do, or some of us do, when we are encountered with a large data set, and we had to figure out where in this particular data set there is value, there is insight. So if you think about the whole workflow, this is what he receives, right? So he has this crazy input with the needle, he does some processing, and you get a needle and a lot of noise, like something that you're not looking forward to, but you just have it as output. You just don't know what to do with it. And you can draw a same analogous workflow for what we do, or what someone who is trying to analyze social data or web data would do with text, right? So here we are receiving text from the whole web. We are basically monitoring over 20 million sources, every day receiving around 6 million articles. Then this whole big blob of text only contains a very small part of actionable information, which is what I call as the alpha, right? And then we do some levels of processing, and we are able to basically distinguish between the two with a very low noise, which is what I'm going to talk about in the mid of the talk. But if you think about the total overload that there is, right? In every single step, there is a huge constraint. So the first step, you have a big data storage problem. So you are actually, for the first time, dealing with big data, and it is a lot of data. So just this, I think our storage costs as much as our real-time processing engines, just to create a single backup. And if you are doing 3 backups, a standard big data way, you want to run multiple models on 3 different backups, you are basically looking at 3x to 5x infrastructure cost. Right? So storage backup and management, it's a big issue. So anyone who is trying to develop an in-house system which tries to extract alpha from text data, basically from the whole data that you receive from the World Wide Web, will have to basically go through one of these constraints. The second is, in terms of processing, we have things like ambiguity, right, in the text. And we spend a lot of time. So there's another very beautiful thing that, thankfully, at NYU, we do a lot of research in deep learning and trying to extract information from unstructured data. So ambiguity is something which is complex to take care of unless you have some level of experience. And then the process is very time consuming as well, right? You need a dedicated infrastructure. Last week, NVIDIA launched the new GPU where they are basically showing how you can crunch much more data at a lower level, at a lower time frame.
You look at text only?
Right now, we only look at text, yes. And then there's manual labor involved. And I'm going to talk about why manual labor is important, especially, so of course, there is a notion that deep learning can do everything, right? I myself have spent good amount of time. We have spent good amount of time in trying to create versions of the feed, which is completely automatic. And there are some pros and cons of it. So manual labor, for now, you need to consider that as something that you need to incorporate in your workflow. And at last, you have a return on investment component, which is how much alpha are you receiving from all the things that you took care of. Is your ROI even high? That said, someone may have this notion that, okay, this looks too complicated, why bother, right? We are all happy and making profit of the fundamental and market data. But there are some really interesting use cases. So every week we post a use case where we try to show what is nice about our data, right? And we try to identify certain scenarios where we are able to identify some information either earlier or we are able to predict some movement in the market. And if you go on our website, we have a use cases tab where you can find a lot of these use cases. So this is what we posted last week, right? So early access, it's a very interesting thing. We very often find that new information or information that actually has an effect on the market gets released on very low traffic sources first. And we have levels of use cases where we try to show the different traffic information, like some blog post which was made only a week ago with literally no traffic is posting information 4 hours earlier than Bloomberg, right? So here is an example where we found this information about IBM acquiring Global 11 hours before Reuters posted it, right? So after we identified from a website called Recode, and then there are some metrics which is difficult to say with, but it is the sentiment was positive, the source rank, one of our metrics which tries to predict how timely this information is and what is the probability that this information may actually get reposted by others, not through a backlink, but like semantically similar information will get reposted. And then we have another metric called saturation, which is how many people have actually seen this information since the time it was actually posted, right? So we have a model which tries to predict for every company, for all the 8,000 US equity stocks, what is the saturation level for every event. So when there is a merger and acquisition for IBM, historically, how many people have seen this information? Today, how many people have seen this information? Then it tries to predict whether the saturation is low, medium, or high, right? So early access, we have a lot of use cases which we can show probably offline as well, where we found it at Recode around 2 hours later. It was published by Seeking Alpha. Then 2 hours later, it was published by Benzinga. And then the next day, when the market opens, the stock sold by 2%. So that was. Then there were a couple of articles which talked about why this might have affected the stock prices. Go ahead.
What was actually posted on that blog?
So it was actually the article itself. So it said that IBM is about to acquire Blue Wolf for this much money, right? All right, and then you can of course incorporate it in your trading strategies. You can have a general sentiment-based strategy. You can have an exposure-based exit strategy. Like whenever an information is exposed to a lot of people, probably you close the position for that particular stock. And then there are.
Shouldn't the stock have been halted?
Sorry, come on.
Shouldn't the stock have been halted? Like before any news went out, right? And like, we're 2 hours early, so we're inside the SEC news, but really that seems pretty dodgy.
Right, so here the market actually closed, right? So you don't really see an effect. So between the market close and market open, that's where the movement happened, right? So when the next day when the market opened, the stock already sold, right? So you could have taken a position after market on this, right? All right, and then you can do something like general sentiment trend following. There are lots of strategies on Quantopian community. You can just go and clone them and see how they look.
So how do we identify this news that came out that's useful? I mean, somebody can post anything like somewhere, somebody about something.
Sure. So that's where some of our metrics come in place, which try to give a layer of credibility in the information. So and we actually did a test run, I think last year, where a random blog on a random blog we posted Apple fired Tim Cook, but it said that the source rank is actually 1, which is like super low. So you cannot trust the information coming from that source unless there is a prior effect, unless there is a historical effect or a historical trend that you can find associated with that source, right? So there is a layer of reliability associated, for which you can use one of our metrics as a proxy. Okay. All right. So of course you can do it. It seems natural to at least have a look at some of these data sources and try to play with it. And some of us also want to build in-house solutions so that like no one else gets to know what we are doing with the feed. But then there is one big problem. There is one big problem in terms of big data aspect of this whole issue. So the first is that big data is getting bigger, right? It's a known fact. In last 1 year, basically one Accern year, which is 2015. In 2015, we crunched more than 200 terabytes of data. So that's not only the real-time feed, but it's also the amount of data that our models used to recompute some of their weights, right? So the total amount of data that was used by a system which just analyzes data, adds some metrics and delivers through a noise cancellation mechanism is more than 200 terabytes, or more than 7 billion articles that we analyzed in last year alone, right? So that's the first aspect of this problem. But the problem is actually again twofolds. The second aspect, which makes that's where a sophisticated solution like ours comes in place, is the alpha to noise ratio is actually decreasing. So it doesn't mean that tomorrow when you have 10 million more articles coming in, you will get the same percentage of articles as actionable as well, right? So back in 2014, we were analyzing 4 million articles a day, but we were able to deliver 14,000 every day, which we felt was authentic and reliable, and you could basically have some trading strategies around it. In 2016, we are receiving, this is a metric from last month, we are receiving approximately 6 million articles a day, but we are only able to deliver 17,000 now. So the input actually increased by 50%, but the output only increased by what, 20%, 21%. So this is a very template, non-scalable big data solution then. So if you are building something in-house, over a period of time, you are actually only grabbing a lot of noise and only pouring out a lot of noise, right? So you need to have a solution that is scalable enough that tries to increase this ratio of alpha to noise. Okay, so how do you increase this ratio? Of course, you want to build a mechanism, a system that helps you increase this ratio. But simply speaking, you can either increase your alpha or relevant information. So instead of delivering 17,000 a day, you can set your threshold lower, and now you're delivering 100,000 a day, right? And then suddenly, as a data provider, you can go and say that, hey, you will get 100,000 articles actionable every day from our feed. Or you can try to decrease noise. Right? So with respect to, so in this talk, I'm going to actually cover majority of decreased noise and part of how to increase alpha. All right, so any system that tries to cover this space of how to increase your alpha to noise ratio will have to tackle these three, will have to take into account these three very practical points. And these are the points that I put considering that you may want to build your own solution in-house, or at least you get an understanding of how something like this works, right? So first thing, which is the most important thing, you need to have an extremely reliable training data to train all your models. Not just the model that help you predict the outcome variable or help you predict a specific metric, but every single layer of your whole analytics pipeline needs to have an extremely reliable data to train on. And it requires a lot of manual labor. I'm not saying that it won't. So we built 3 different systems to just do that component. So maybe eventually you will build more systems just to train, just to create training data than what your final outcome is. But it is an extremely important step. Even if you have a small sample of training data, you have all these different approaches in which you can replicate the training data with some variation, but always use a very reliable training data set, even if it is small, to start to train your data, to train your model. The second component is noise filters. Now, if you read carefully, I actually use the term not a single filter. There is a notion, and some people believe that, and we actually also tried that, that you can have a big cluster of spam filter which uses just the text data, and it uses a multi-layer deep neural network, and it just magically says whether it's a spam or not a spam. Trust me, infrastructure-wise, it is extremely expensive. It's extremely expensive. You even just training a model like that is going to cost you a fortune at times, right? It's not that it doesn't perform well. It kind of performs good, but you may want to avoid that just because of the infrastructure cost and how. And of course to reduce latency. So I'm going to go through this particular step by showing how the Accern noise cancellation pipeline looks like, but just keep that into account that you will have to segment your whole noise cancellation process into different modules. Now, the way you sequence them needs to be in the increasing order of how much they cost you infrastructure-wise or computational complexity-wise. And I'm going to actually give you an example later. And the third is the relevancy model, which is your secret ingredient, which is where you need to define what is relevant to you. And this is a super generic template that you can apply on any noise cancellation filter that you write. Okay. So, just for an example's sake, I cannot see the colors. They're not here. Okay, anyway. So I'm going to go from the top left towards like the whole pipeline process, right? So the first three components that you see are the spam reduction components. And the last three components that you see are the relevancy components in our pipeline. The first thing that we do when we, and this is a very simplified version, just to make it more understandable. So whenever we get a new data coming from anywhere, we first try to see whether it comes from a usual suspect. Like, is it a site which somehow adds a word apple to throw out some very relevant information, and the kind of information you don't even want to show to a client who may actually come back to you and say that, hey, just because you saw a specific word, you said that the article sentiment is negative. So these are the bad data. You have a blacklist of sources where you say that, okay, there is complete no when any article comes from these specific sources. The second component, so this is computationally this is the cheapest, because all you have to do is check what the source is, and you just accept or reject data from the source. The second component is the structured spam. Now, structured spams are things like coupon deals, right? Often you see there's a new Amazon coupon deal, there's a new Walmart coupon deal, or there are other like very structured spams that you can just remove by writing a regex function, right? So you can write a regular expression saying that, hey, every time there is an article which mentions a company or which mentions Amazon and coupon deal, just make sure that it fits this particular pattern, and if it fits this particular pattern, just reject it. Right? Super simple. Again, doesn't require a lot of computational complexity, and super cheap to implement. The third is where the magical component takes place in terms of spam reduction. So we built an ensemble of spam classifiers, which is a series of machine learning models which try to predict parallelly whether this article is a spam or not a spam. And if it's a spam, then you have a way to create a consensus across all the models, right? That's a standard ensemble learning, where you say that, hey, 70 out of 100 models said that this article is a spam, so maybe it's a spam, right? You can do something super simple with this one.
Do you have reactive spam filtering? Like you try to react on the new emergent kind of spam within like hours?
Sorry, don't get.
Like, is your spam, how reactive is your spam fighting here?
Reactive in terms of?
In terms of like, suppose like some new spam appears and with a new kind of pattern, how fast you incorporate it?
So, okay, so from receiving the data to going to the analytics pipeline, it requires 40 milliseconds per article.
No. So suppose like right now I start spamming the whole internet with Apple slash, I don't know, like
how fast will
watches.
this pick it up?
Yeah, how fast your spam filter is going to pick this up?
Sure. So it won't be picking it up at this place, because it's not hard coded, right, in our regular pattern list. But ideally, it should be picked up somewhere here, because here we have an ensemble. Right?
How fast does it have to? Is it after he sends out 10 spams, will it pick it up and start rejecting it, or will it take days?
No, it won't take days. So everything from here to here, even if it's a new data, if the data is never seen by the pipeline or the models, it will never take more than 50 milliseconds. That's the whole pipeline timing, right? But if let's say you start spamming us and somehow the crawlers are picking your data and throwing it in the pipeline, it will not get rejected here and here, because we don't have that information. But hopefully it will get rejected here, because we have an ensemble of machine learning classifiers.
So right here, do they get updated every day, or is it like?
So okay,
how
yeah.
often?
So every 14 days we update all our models, and like we took that decision after like a lot of balancing between the cost itself of retraining everything and how much data we actually want to add every time.
I don't know if you said this, but how do you classify the spam? So like spam on Twitter may be different from spam somewhere else. How do you classify it?
Right. Okay. So we have around 700 something million tagged articles so far out of 7 billion that we crunch. Right. So we have a huge data set of training, like huge training data set. Now out of that 7 million, we can use most of it, not all of it, for spam versus not spam, because not all of it, you cannot just overfit everything, right? So every time we just take a sample of it, we do some simulation and we try to see what's the prediction. So whenever the prediction goes below a certain threshold, we try to again check the last training data that the model used to retrain itself, and we throw it into one of our tools that I mentioned here, just to check whether the tagging was reliable or not.
How many sources are you using?
20 million data sources. Yeah. So it's basically everything except Twitter as of now.
You're not using Twitter.
We are not using Twitter as of now, and there are good reasons for it, because some of our models, there are basically two aspects. One is that last year we posted a long article around how many articles get first mention. So we have a metric called first mention. How many articles get a first mention on Twitter versus how many of them get a first mention on very low exposed sources. And it's like a equal playing ground here. Like, it's not that everything first comes on Twitter. Very often it first comes on very low exposed sources, and then it gets picked from on Twitter and stuff.
Sorry to talk about this a little bit more, but your data sources, is this like Wall Street Journal, Financial Times, typical news sources? You're not using Twitter, but using like stock tweets? I mean, you know, some zero? I mean, could you give us a sense what this looks like? Or are these mommy blogs?
So, yes, that's a good one. It actually covers all the news sources and all the blogs that are out there. So every .tumblr is there. Every .blogspot is there. Every .wordpress is there. Okay. Go ahead.
So when you get a news story, I assume some of them have metadata attached to the story that you could also use to your, like do you put it in a category like this is a commodity story, and how do you, like, if you pick your own category but then the metadata said this is this kind of story, how do you take it?
So that's a component in the pipeline. I'm not really covering that as of now, but whenever there is a conflict, so as of now we don't rely on the metadata that comes with the news, right? Because then there has to be another layer which needs to predict whether the metadata is correct or not, right? Or we just assume that the metadata that comes in is correct, and then we basically veto our own prediction. We say that, okay, the metadata said it's about mergers and acquisition, but we think that it's about lawsuit. So so yeah, we don't cover that aspect yet.
But like when you trained your network to, let's say, label the topic of an article,
yep.
like the training set you're using was already labeled by the original metadata, or like how did you make the training set?
Sure. So that basically goes back to the training, creating a training data. So for spam, it was easier, right? I mean, you can just predict whether it's a spam or not, and let crowdsource the whole platform and let people tag whether it's a spam or not. For things like topic modeling, I'm going to tell you exactly what happens in one of the strategies that I show. But with respect to topic modeling, we follow something much simpler. So we have a huge taxonomy of every financial entity, right? So if it's Apple, it has all the variations in which Apple appears. So think of it as an ontology on top of which basically tries to contain all the variations in which people can mention a specific company, right? So this is more like a bag of words approach, but it's not it's not a unigram, it's more like n-gram. So it tries to see whether this particular word appears with another particular word. So that's the thing that I want to cover actually here. So we are actually trying to reduce the spams. Then, so basically what I just mentioned comes here, financial mapping, right? So far there is no finance specific component till this point. Then we do something called language rules. It tries to see whether there is a subject, whether there is an action associated to the subject, whether we should actually call it as a relevant information. After that, we Yeah, I'll try to basically cover the whole thing because we are doing Q&A in between, so it should be fine. All right. So after that, we use the financial mapping taxonomies. So now these two taxonomies, the first taxonomy predicts the entity itself. It helps us predict what is the security that is mentioned in this article. The second taxonomy tries to predict the topic itself. So we have around 30,000 topic variations, which are very, very specific to finance. So we use that along with the security mapping to basically make sure that the article fits the language rules. That is, there is a security mentioned and then there is an action mentioned about the security. So for example, there is lawsuit associated with Apple. There is mergers and acquisition associated with IBM in that example.
Just a quick question. So
Yeah.
if you read a news story from the Financial Times, or they do an in-depth story about European regulators going after Google and some of its peers, chances are they will mention at least 10 different publicly traded companies
Yes.
in that one news article.
Right.
So when you go through your pipeline here, how do you attribute, because all the examples you mentioned here just say Apple lawsuit.
Right. Yes. So I mentioned only one, but yes, we do relevancy scoring, and that's where your secret ingredient component comes. So a very simple heuristic, something that you guys can try on your own. Whenever you see an article, it's actually one of the research papers published a couple of years ago on how people read information on the web, right? So usually the top part of the article and the bottom part of the article is the most relevant, right? So people want to see what's the abstract. People want to see whether there is a conclusion or a summary written, right? So you can actually model themes within an article based on where a specific security is mentioned. So if there is an analyst rating, so usually analyst rating related articles have 20 different securities associated, right? So in the body, they say the analyst gave this article, this security this much, this security this much. So there are two aspects. If the system feels that there is not a huge variance between the relevance scoring of all the securities, it is going to create multiple copies of the same article and associate the tags to each of these copies, right? So if an article mentions 5 companies, it's going to create 5 copies and say that first copy is associated to this, second copy is associated to this, something like that. If it finds that there are only, like I'm just trying to tell you a gist of it, but if there are 2 or 3, but they don't share similar scores, it is going to neglect one of them, right? Maybe there is a specific security which is super low in terms of relevancy score. It's just going to reject that. So that is what happens here. Go ahead.
Yes, you mentioned you're analyzing text. Are you also ingesting things like search terms being used and conversions and purchases, and product level ID type of things, like that type of data into the model? In the model?
Not yet. No, we wanted to bring something like Google Trends in here, but I think once we show you like the new platform that we built, I think we can actually model that component based on what you search on our platform itself, right? Okay, so by the time the data moves from here to here, we have less than 3% noise, which is actually quite cool. And I'm going to tell you what is the implication of this at the end. All right, so okay, we have little time, but anyway. So let's do a very quick performance comparison. Like when you do a sophisticated noise cancellation mechanism, how does your performance change in terms of a very simple trading strategy that you use? Basically, a very simple trading strategy which is long only. So buy stocks based on the sentiment score of the article, right? And it is on the alpha 1 data set, which is the daily aggregate. So you are only taking decision once in a day, basically when the market opens with a holding period of 1 day, right? Okay, metrics that we're going to use are average daily sentiment, which is the sentiment average aggregated in last 24 hours, and then impact, which is the probability that the probability that the stock prices may change by more than 1% end of the day. And it's an absolute number, so they can actually surge by more than 1% or slump by more than 1%. And it utilizes some historical information, something like in last 2 years, every time there was a lawsuit mentioned with a particular company or an acquisition mentioned with IBM, was there an impact on the stock price? It's still a heuristic, but it kind of gives you a very good sense of what might happen. Okay, and then we use 3 different models to compare. The standard model, which uses the Stanford Core NLP, very standard, lots of people are using it these days, so we thought that that's a good benchmark to test. It uses Python and LTK as well for sentiment. So we basically do, so this is a classifier, this is more like a regression model, but we basically convert the two into a single score. Right, and then we have impact, which is based on, again, Core NLP's entity extraction algorithm. And then we use the training data for spam cancellation, which is Enron. There's an open source spam data set that you can use to train your models, right? The second model, we use the Accern impact, which is trained on the data that is crunched from the Exxon pipeline, right? So we just use the whole impact model as it is. And then the last one, we use our own sentiment, our own impact, and the training data is the data that is passed through the noise cancellation pipeline, right? 3 different constraints. First is that the models can only trade on common equities. Basically, if one model is trading on Apple, only if all three models are trying to take a position on Apple, then only take a position on Apple, right? So that you have a very fair comparison. Then each model can use the best configuration, so there is no constraint around the configuration. So if the first model can use a sentiment score of greater than 0.5, the other can use 0.7 if that leads to the best result. And then we have a 2-year trading period. All right, I'm going to walk through very quickly. All right, so the standard model, you see, okay, so the top line, which is the red one, is the benchmark for SPY. The blue one, it's all run on, or it's all simulated on Quantopian platforms, so you can actually go and check them there. So, bad results, basically.
Well, you could short it.
Yes.
Short everything.
Okay.
And then raise some money for this, right?
Right. So that's the reason why I showed this one. Like there were other which looked even worse in terms of the inconsistency. Now, this is where the whole notion of how balanced do you want to make your decision, right? So do you want to just trade on an article where the model predicts go by because it has mention of the word the 4 times? Like these are actually the outputs. So if you look into some of these models, if you look at what words they are using to predict, you see that very often they use stop words. The sequencing of stop words is what is leading, making them predict a positive sentiment or negative sentiment or go buy stocks, right? So it's, yeah, this is a whole discussion. So that's the reason I wanted to put it here, so that people who want to talk, I can actually have a chat with them about this. It's actually quite interesting. So you just invert it and you may see a good performance.
I'm curious to see what contribution each step you had makes, right? From the first model to the blended model to your model, right? And you sort of see the cumulative returns of that. Because ideally you want to see that yours is adding more value.
Sure.
Right? Do you have any results on
Yeah.
that?
So this is using the standard one,
Okay.
right? This is using the standard plus Accern impact, right? So here it is trying to make sure that your trades only happen when a specific sentiment score, a specific impact score happens.
So your impact is really important here. That's what
So
it's
yes,
called.
so the impact basically makes you, so it doesn't tell you the direction of your strategy. It doesn't say that you'll go long and short, but it makes sure, the magnitude itself, right? So you can set a specific magnitude.
And what did you set that magnitude at? Was it like 90%?
So yeah, so in this one it was 85.
85, okay.
Yep.
So then I'm assuming that the next slide I have to guess is even better.
It is better.
Okay.
It works.
Yay!
We all should just go and subscribe now. Sorry, someone had a question.
Yeah, I'm just a little confused about what you're actually doing. So like every day you have all like the news analysis,
Yes.
and then you like pick a certain number of stocks to buy for that day based on the assumption that they're going to increase in value.
Mhm.
So
Yeah.
so every day there's a new portfolio of stocks that this strategy is owning, and it exits them at the end of every day.
No, so it actually runs on all S&P 500, right? So you are actually covering the whole universe.
So you
Right.
allocate a percent of your portfolio to each stock based on this.
Whether it satisfies our long criteria or not. So here our long criteria was, for example, in this one it was the sentiment should be greater than 0.6 and the impact should be greater than 90.
So for each stock in the S&P, there's two input variables, and then you have two parameters that you're tuning to get the best results?
Yes.
Okay.
Yeah.
But what's weird is that you put in blogs, but you spam filter emails with the Enron, right?
That's the only open source.
Oh, okay, I'm just trying to understand,
Yeah.
right?
Yeah.
And these are newsletters, it's not Twitter, so it's not like this instantaneous stuff. These are long blogs presumably, right?
Yeah. So these are not 140 characters.
Yeah.
These are usual article length size emails.
Oh, I'm sorry. Also, are the positions changed like once a day, or how?
Yes.
So
You only hold for a day.
so how does it work with so the positions are all entered like in the morning,
Yes.
and then they're all closed at night,
Yes.
and all the news was published
To
the
at
night
midnight.
before.
Yes. Like the day before.
Okay. So okay.
I think what would help is to understand like how many stocks are in this portfolio over time, right? We know it's all long.
Yeah,
We
yeah.
know the universe is about 500, but
Mhm.
is it like, 300, 20 each day?
Mhm.
Or is it, does the numbers go in and out like
Sure,
crazy, right?
Yeah, so all the strategies that I'm going to show here are all on Quantopian platform. So you can just go and it basically tells you how many longs and shorts happen.
Approximately, just give us a flavor.
So on average, it takes position on around 40 stocks a day.
40.
Yeah, 40. Yeah. Okay. And then there is another strategy which was posted 3 days ago by Song from Quantopian. You can actually check it out. It's on drift following. So this is on a 1-year backtest data, and then he also did on out of sample data, so you can see how the same strategy performed in last 2 years as well. So there was no basically big difference in the performance. So you actually still see the similar performance.
Okay, so explain it. What is drift following?
It's basically trend following here, right? So you take a 40 days article sentiment average in last 40 days,
Yeah.
right? It's like moving average, right? And then based on that, you have the similar criteria that you had here,
Yeah.
right? And then you make a decision based on that.
So buying and holding just for a day?
Yes.
Wait. So
No, it has a weekly holding period. Sorry.
Oh,
So the previous strategy was only looking at stories in the past 24 hours
Yeah.
and making a decision based on that, or
Right.
the past 8 hours. I don't know.
Yeah, it
And
was
it's
looking
the
at
past
on.
40 days holding for a week.
Yes.
Okay.
Okay. Now, then there are some alpha stream strategies. So far what we saw, the benefits of having good training data was we got a more reliable model. The models were leading to better, to higher output variables or better alpha, right? But there is also another interesting factor here. When you have reliable data, you can do much more sophisticated factor analysis, and you can drive many more different kind of metrics out of it. So I'm going to show you something super simple that we did, and this was one of the strategies that went viral on Quantopian. It had like 10,000, 11,000 views or something. Okay, very quickly. All right. So it basically uses a couple of metrics that we derived just because we had the ability to derive some interesting metrics from a very clean data set. So it uses a metric called event impact on entity. So historically, a similar event, how it affected a specific entity, right? It has another metric called first mention, whether this article is the first mention in the market so far. Is this the first information about this particular event today, right? Basically in last 14 days, but like Yeah. And then it also uses something called source rank, which is one of our metrics that tries to predict, which is the same metric that I showed in the IBM acquisition example. It tries to predict what is going to be the virality of this information. Can you trust this information in terms of in next couple of days, lots of other people are going to talk about similar information, right? So we created a buy and sell condition. Again, you can find it on Quantopian, clone it. And lastly,
you said trust and virality are the same thing.
No, source rank actually takes two factors into account.
Oh, okay.
It takes the timeliness of a story to come in the market from a specific source. So how timely is a particular source in posting a specific story or a specific type of story. The second is what is the volume or what is the total exposure of similar information once this story is posted, right? So over next 10 days, do a lot of people actually talk about similar story, right? So that's what it takes into account. It's a two-factor analysis.
How sensitive are the results to these parameters? And like, is it computationally very intensive, or can you quickly change the parameters and see how the results do?
You can, yes, so that's what I'm going to show you next. Okay, so this is the last slide, actually. All right, so all of this, we data scientists are skeptical by nature, right? I mean, we want to question everything. And there is a beautiful quote in the data science world which says, yeah, if you torture the data enough, it will confess to anything. And there are websites which show you the correlation between the path that ice cream trucks follow versus the homicides in New York City. Like, you can see a very high correlation, and you cannot just say that, okay, whenever there is an ice cream truck, people get killed, right? So we are skeptical by nature. So in terms of the benefits of having clean data is something we believe is the first step in something revolutionary that may happen in the whole space of social analytics, which is transparency. A lot of people have been talking about machine learning as a black box, right? It's easy to get away with, actually. Like, you can just say that, that prediction comes from my deep learning model, which is 18 layers. Anything that you predict is just based on that model. So I cannot show you the actual article title or actual article content. So we actually faced similar queries in last 1 year. People came to us. They said that, hey, your model performed amazing in January and February. Then in March it slumped, and in April it did really well. Can you show me the difference between the articles that you received in these 4 months, right? For us, it was very easy, actually. Like, we actually sent the whole data blob. We said, okay, just have a look at it. But we've realized that that's a big problem, which some of us have not been trying to solve, unfortunately. So just for in an ideal world where everything needs to be transparent, we created this very simple visual analytics platform. Okay, we call it just app.exxon.com. You can go subscribe for 14 days free trial. It actually runs on Alpha Stream, right? So everything is real time. It basically shows you all the events that happened. It visualizes your whole web. Everything that you receive in Alpha Stream, 8,000 equities, data coming every second, every millisecond. And it plots your sentiment score. You can interact with every single component that you see. You can see why did the sentiment here slump. You click on that, you create a range, you see all the articles as they appear. You can create your configurations. So you can basically, the beauty of it is you can simulate your trading strategies on this platform. So whatever long and short strategies you created on Quantopian, you can just come here, create a configuration. You say that, hey, every time the sentiment is very positive, so there's no numerical value. We actually bin them into 5 different levels. And source rank is 10, and people are talking about financial actions for a specific company. You go and long, right? So you can actually simulate such kind of behavior here, which is actually quite interesting. So I would say that go play around with it and let us know what your feedback is. And it has been in closed beta for a month now. As I speak, we are going live for everyone. So you get a 14 days free trial, and let us know what your thoughts are. That's it. Thank you so much.